Welcome. I'd like to do something a little different here. This, what you're seeing on the screen, in the center at least, is a program called Evolution, which is a sort of simulation, emulation, depending on how you look at it. And I'm going to give it my own term, but I'll get to that in a moment. For now, here's a little demonstration of how the thing works. Just put a couple of joints in here and throw a bone in between them and hit evolve, and you can watch that thing drop to the ground. What that is actually is a simulation of physics. Now, a simulation of physics like that is ran in what's called a physics engine. Physics engine actually has, for lack of a better way of putting it, non-physical physics. In other words, it has a system of physics that runs entirely on mathematics and behaves according to its own set of rules. Generally, rules intended to simulate or, if possible, emulate the actual physics of our own physical environment, our reality that we live in. Although physics engines can have their own unique physics, intentionally much different than the physics that we live in as our reality. If I add another joint here and another bone, now I have two bones. I can put a muscle in between, and I can hit evolve again, and you'll see it actually is putting several copies of this thing into the environment and letting them all do their little thing. And here's a second generation of them. And basically what it's doing in this case is I've given it a task of trying to run or move to the right in the screen. Now, I didn't choose to the right. That's programmed in. But the program itself is measuring how good these things are at moving to the right. And what's actually evolving isn't the form of these things. It's a neural network that decides how they behave. So when I go back to the main screen and I click evolve again, it's starting all over with the evolution. We're back to the same shape. And once again, it randomizes the neural network for the population, in this case, 10 individuals, and it tries them out to see how each behavior manages to succeed or fail at the given task. And those that have more success are more likely to be used in breeding neural networks for future generations. So this is not what most people would think of when talking about when the term evolution comes up. Although it's technically not really a simulation of evolution, it is evolution. Because with each generation, changes accumulate in the neural networks that are being inherited from previous generations. And the accumulation of change is evolution. So in this case, it's not evolving bodies. It's literally evolving brains. No, not biological brains. These are brains of a different sort. They're neural network brains running on a computer program. So enough of that. What I want to do is I want to review some suggestions that other people have made, and eventually some that I've made for the programmer of this particular program. You can see his name over here, Keiwan. I don't know if I'm pronouncing that right, but that is the developer of this program. And there's a lot of there are a lot of programs out there that use evolution in one way or another, and they're all very different from each other. there's been a lot of attention around this particular one, and also I would say a lot of confusion around it, because a lot of people don't really know what to make of it being called evolution, and not seeing anything that they recognize as evolution at a conscious level, and yet somewhere in their vocabulary it just seems to sort of match that there's something going on that fits. So I hope that I can shed a little light on that, with my comments about how it's actually not an evolution simulation. It is actually um, evolution that's going on in there. Uh, Now, you could consider that a simulation of biological evolution of brains, in a sense, except that biological brains are physical things, and as they evolve they change their physical form, and as the things the brains are evolving in evolve, other stuff about their physical form generally evolves as well. Now, that's something I'm actually suggesting later on. I'll get to that. That could be added to this program, and I'm not the only one to suggest it. Apparently, I took a glimpse at some of the other suggestions before going ahead and doing this, but for the most part, I have not read them yet. So I'm going to be reviewing them, reading them, and discovering a lot of what people have to say as I go along. And I have set aside a space for myself to record some comments and inspirations. And so I want to begin there. This is the page I've opened up at editpad.org. And I've typed in this little bit of information here, notes and suggestions concerning the evolution program named Evolution, at https://keiwan.itch.io/evolution. Now, notice I put evolution program, and you can see I've got Grammarly running on here, and it does not recognize that word. Well, it's because it's a term I made up because I don't know any better thing to call this. And so my first suggestion is having to do with that term, and I'll get to that when I finish, when I read down that far. So, next paragraph here, reviewing the first 10 items at https://itch.io/t/226417/suggestions-ideas after equals 0. So these are the ideas after 0. Now I want to make a comment here. Generally speaking, that page will display 20 at a time, as far as I know. Now maybe on different devices it may be different. I've went through a little extra effort here to only show 10 at a time, and so that's what I'm going to have. But if you open that page, I expect you're going to see 20 of them, starting with the 10 that I'm going to be reviewing here. Suggestions and ideas, entries number 1 through 10. Inspired notes. I'm suggesting the use of the term evolation as an extension of the family of words including simulation and emulation. The word evolation is formed from evo, used as a prefix, and lation, meaning local motion or local disturbance, and indicating a local system of change. In other words, indicating a system of evolutionary relation as conforming to, generated by, or viewed from the perspective of local conditions. I would consider the program we're looking at here, this evolution program, to be an evolation of evolution in that sense. Another way of looking at it is you could call it an evolution engine, in the same sense that the physics in the program is produced by a physics engine. This is actually, it's sort of an archaic or obsolete word, lation, but I'm sort of reviving it here with a prefix added. Now, Evo or Evo has been used as a short form of evolution. It's also occasionally used as a prefix. So this is not adding anything really new to the language. I'm just trying to make something that makes sense here because, as I said, actually calling it a simulation of evolution is technically not an accurate way of describing it. I would call it an evolution engine, and the reason why I would call it an evolution engine is the same reason that that the physics environment in the program is considered a physics engine. But for shorter, simpler usage, I think the term evolution um, fits the bill. So, moving on to the actual suggestions. I'm going to start with the post by Keiwan himself or herself. I don't know which is the case. Lemself, I'll say that's gender neutral. Keiwan Lemself has posted, if you have any features you would like to see in a future version of this simulator, you can post your suggestions here or just upvote the ones you like the most. And I like that suggestion, so upvote that. Now, I don't expect I'm going to be able to pronounce most of these names right. I may make a stab at them or just say, read it off the screen. I don't know. But this one looks like Fisting Jamboree. 28 days ago, made a suggestion of an obstacle mode for both running and climbing. Now, running is one of the tests that can be done, one of the fitness tests that can be done in the evolution program. And climbing is another. Now, I have some suggestions we'll get to later on how to improve both of those. The way it is right now, combining the running and climbing, I don't think you'd really be able to get anything that would make any reasonable progress at all. Now, I could be wrong, but I think it would take a lot of effort to design something that would be able to do them both. You wouldn't have much luck just starting out with something simple and making little tweaks to it as you go. Now, again, I could be wrong, but that's my assessment. However, because I do have suggestions that I think will make this a viable suggestion, I'm going to go ahead and upvote it. And I do think that it's a good suggestion overall to be able to combine those things and give something a little more challenging for the life forms or whatever you want to call them, the things that you build to evolve their neural networks in, or evolve whatever they may happen to evolve in future versions of the program. Now, I don't know if Keiwan is still editing this program or has given it up or whatever. Hopefully this video will catch Liz' attention eventually and not be a waste of my time in that sense. But if nothing else, hopefully it'll be a little entertainment for whoever decides to watch this video, which is one of the reasons why I'm keeping it down to 10 of these, because I want to keep it short, and I'll continue on in a separate video with more of them. J-Time Game, 28 days ago, made the comment, I know that it's not about feature for the simulator, but I think it would be useful and cool if it was on STEM. Now, Steam. Now, I don't personally know what the benefits of that would be, so I'm not going to go ahead and upvote this one. If there are other people out there who think that's a good suggestion, I recommend going and upvoting that. As a matter of fact, I'd say any of these that you really like, that you really think you'd like to see in the program, go and upvote them. I will be upvoting the ones that I personally can see benefit for, and I don't think I've used the Steam. I know of it. Um, I don't think I've used it at all. I may have, and if so, not really enough to be able to comment on it or even remember exactly how it works. Um, but it seems to me it's some sort of a program sharing something or other. And yeah, any rate, Red Dog 34 says maybe a way to see how far slash good your creatures are, maybe by adding meter slash feet lines in the floor slash background. Now, I would think there would be a better way to do that rather than, and the lines and stuff might be good. I noticed the background is sort of hard to even see. It's moving. It might be nice to have some stark contrast in the ground image, or whatever you want to call it, the thing that stuff is that the items are running or walking on. Um, and putting a number in there every so often, that would be one way to have something that would nicely show going by, even if it was just like 0 1 2 3 4 5 6 7 8 9 0 1 2 3 4 5 6 7 8 9. It wouldn't even have to go into two digits, just repeat. And if they manage to get that far, well then it would still give you a way of sort of keeping track and sort of gauging how far something managed to run or climb. But I would say having just a number, a maximum number reached, how far to the right or how far up or whatever's being measured, displayed somewhere on the screen might be a better way of doing that. Now, again, I could put that in my notes. I'm not going to do that for now because I don't think I want to actually make that suggestion formally. But it's mentioned on here, and if the programmer happens to come across it and likes it, well, okay, then it's there. If somebody else wants to put it in there, if they don't see it already added, then so be it. There is but I'm going to go ahead and upvote this anyway. Now there is a reply to this one, and I see this one's now that I've upvoted it, now has a +5. The reply by Mainkins.Paul says, yeah, display the score in meters or feet of the last generation's best creature and the score of the current generation's best creature. Good job. So apparently that person is thinking along the same lines as I am, of showing it as a sort of score as opposed to something actually in the environment to be able to measure it by. But they're both good suggestions, in my opinion. And as a matter of fact, I'll go ahead and just upvote this, and then that's sort of like having already posted that myself. So good thing I didn't bother to put it in my notes because, yeah, that's taken care of. Again, I don't know whether or not it'll be seen by the developer, but even if the developer of this particular program doesn't happen to see these, and I see they have seen at least some of it because there's a reply from the developer here. But even if there are things in this list that don't get seen by Keiwan, they might get seen by someone else who's making a program inspired by this one, or maybe is making their own program that has nothing to do with this one, but that the suggestions for this program may help theirs. And at the very least, if nothing else, it's stuff for some people to think about, and I think that's that's good. Inspiring thought is good. So Zagman says, I would like to be able to alter the simulation time and the rate of mutation during the evolve process. Okay, that already exists in there. Good work. And Keiwan says, thanks. You can already do both from the pause menu. I have the program running here. So let's go ahead and have a look at that. Evolve, pause, and here we are. Time per generation and mutation rate. Now, again, I don't know if I want to put it in as a formal suggestion because it's sort of trivial. But I think I would change that to time per cycle or time per batch, because there is this here where you can simulate the generation in batches, and you can set a batch size, and it actually is the time per batch or per group that's being set by this time per generation, which that's in seconds, by the way. 10 is 10 seconds. So, going back here, let's stop that thing first. I could have left it run. What the heck? Maybe, you know what? Let's just do that. Leave it evolve as I'm talking. And who knows? Maybe these not very good at what they're doing things will get better while I'm talking. I see there's one going backward there. Next time I go in there, we might see some progress if I go back in. Okay, continuing on, another reply. Well, this is a reply to Keiwan. Firando says zero gravity running mode, so you can make swimming creatures. 3-dimensional building, 3D creatures able to download other users' creations, weapon attachments, and ultimately multiplayer race / PvP. Now that's a bunch of stuff, and I'm going to go ahead and upvote that. Just because I think that's some good suggestions there. It's unfortunate that they can't be upvoted individually. Now, I like the swimming creatures idea. Anybody who's watching this video who's familiar with Gene Pool or its predecessor, Darwin Pond, should be familiar with the idea of evolving swimming creatures. And there again, they had not really a neural net, but something along such lines that evolved from generation to generation as well. They had a sort of evolving behavior. And so even the exact same form of swimming creature or swimbot in Darwin Pond or Gene Pool could evolve to be better swimmers. And they didn't actually learn, as individuals. But over generations, they could learn instinctually to swim better, so that they're basically born better swimmers. And so I'm going to go ahead and put something in my comments, in my notes, to try to remember to add something along such lines as my own suggestion. And so let's see. I like the zero gravity thing in a sense, but I'm going to put as a suggestion gravity adjustment, or other environment adjustment. I'll keep it that simple. Yeah, there's Grammarly complaining about my grammar again. I want to see what it suggests. Let's see what another changing words. I'm not even sure if I understand its suggestion. Oh, I see. It's piled the words on top of each other. Another environment adjustment. Other environment adjustments. Oh, I see. Um, well, it doesn't really matter, but I'm just going to go ahead and pick that one. Or other environment adjustments. And, I'm going to go and slash or, which is not exactly great grammar, but it gets the idea across. So there's one. And um, environment viscosity to enable flight or swimming. So those are two separate um, suggestions, and I don't know whether or not they'll be understood as intended, but I'm planning on adding them anyway. Very, very simple things. Between the two of them, there should be a lot of possibilities for what sorts of things somebody would be able to design and evolve. And they're gonna. I want to point out for those who haven't seen my earlier videos on this program and aren't real familiar with evolution in the general sense, because I know most people, when they think of evolution, they usually think of some specific subset of biological evolution. Unfortunately, in the case of a lot of people, not one that corresponds to anything in reality, but rather one that they think some people are presenting as reality. And yeah, that's complicated. But evolution, of course, as I mentioned earlier, is the accumulation of change. It's a process. And when you're building things in this program, when you're, for example, in this case, I added in two joints, which I wouldn't have called them joints, but that's the term used in the program. I wouldn't have called them joints before there's a bone, before they're between two bones. But that is the terminology used in the program. So I added in two joints, and I put a bone between the two joints, as opposed to a joint between the two bones. And then I added a third joint, and I put another bone in, and then I added a muscle in. Well, each of those additions is a change. And each of those changes added to what changes have already been put in is part of the evolution of the form of that particular item. And for example, and I'm going to go ahead and back out of this thing. If I delete one joint, okay, when I delete this one joint, it's going to delete the bone that's attached to it directly and the muscle that's attached to that bone directly, because in this program, you can't have a bone without two joints, one on each end, and you can't have a muscle without two bones, one on each end. So I delete the joint, that gets rid of the bone. Getting rid of the bone gets rid of the muscle. So that deletion is one change. Now that puts it back basically in the situation it was in before I added that joint, bone, and muscle. I just undid three changes in a sense. But it seems to me I had moved a couple of things, so there are still changes that were accumulated that haven't been lost. And the deletion of something, the loss of something, even the loss of a change can still be part of evolution. Now, let me see if I can demonstrate that a little further. Let's say I add a joint here and a joint here. And now I add a bone over here on the left That's an added change. It has evolved. It is evolving. Now I add a bone over here on the right. Again, it's continuing to evolve. Each additional change is part of the accumulation of change and therefore part of the evolution. Now, if I deleted this bone, just demonstrate that, delete this bone, I just undid that particular change. So there hasn't been any overall evolution. No change has accumulated from the time it had this form till now, because here it is back in the same form. So you could call the addition of the bone part of the evolution there, but the addition and then removal of the same bone with no intermediate changes doesn't really qualify as evolution, because the change doesn't add up. On the other hand, if I delete this bone, that is still part of the evolution, because it's not bringing it back to a previous state. That change is added to the change of having added this other bone. So even the deletion is an added change. And now I could add another bone here, and that again is part of its evolution. And then I could delete this bone, and that again is part of its evolution. And then I can add a bone here, and that again is part of its evolution. And again, no one change by itself is evolution. It's the process of change accumulating. So now if I click evolve on this, it'll drop that thing on the ground, and it's basically running a neural network that has nothing to do anything on, because there are no muscles. So if I go back in here and I add another muscle, or because I had deleted the one we had before, add a muscle in, now the neural network has something to act on, and I can click evolve and try to evolve a neural network, and you can see it moved, and one of them's still moving. And when that generation is done with its 10 seconds, it starts another generation of 10 individuals. And when that one is done with its 10 seconds, it starts another generation of 10 individuals. And each time it's deciding which ones to breed, partially at random and partially based on how well they did during their 10 seconds at, in this case, moving to the right, which is the test they're being given. Now, you might notice not really a lot of progress here, but then it's only been now 6 generations. But if I go back again and I add another muscle between, I could put it here to there, or I could go, let's say, from here to here. I'm going to do that. So now we have 2 muscles instead of just one. And again, I'm going to click evolve. And one of them jumped quite well. And so again, it has 10 seconds, and then it goes on to the next generation. These things aren't dying of old age per se, but in a sense they could be seen that way. If they're 10 seconds old, basically that generation gets replaced with another. If you don't want to look at it in such a morbid sense, you could say, well, okay, so maybe they're continuing their life elsewhere, but technically these things aren't really alive per se, and also technically they don't really continue elsewhere. When it moves on to the next generation, the space in the computer's memory where they were residing is reclaimed and reused. So they're literally at the end of their 10 seconds going into non-existence, except for, of course, the continuation of their form, which again evolved with my help. So it's both designed and evolved. And of course their neural network um, the basic structure of which was designed, the matrix the neural network works in, but the content of which is initially randomized and then evolves from there. So I'm going to leave that run and let's go back to here. Okay, there's my notes, and returning to this, there's another reply. Yo, zero gravity mode actually sounds effing dope, dude. Um, yeah, I agree. Zagman, LOL, yes. I just found it. I came here to retract my. Oh, that's in response to Keiwan saying you can already do both. Um, uh, that is changing the simulation time and the rate of mutation. Um, K1 came and said, yes, you can do both. And Zagman responds, yes. I came here to retract my suggestion. Thanks for your reply, though. Okay, another idea then maybe you could have an option to let bones slowly evolve in length, especially when most creatures are within a few percent fitness from each other. Um, and I've actually made a similar suggestion to this. It's farther into the suggestions. It's not so much a bone length thing as moving the joints. Lengthening the bone would be another way to do that. Of course, that would push the joint the bone is attached to. Um, and well, I don't know which. I guess it depending on how you lengthen the bone, would it push one joint or push the other joint or push both joints away from the bone center? I don't really know, but nonetheless, it's a good suggestion. So I'm going to go ahead and upvote that as well. Continuing on reading that. Where was I? Okay. Maybe you could have an option to let bones slowly evolve in length, especially when most creatures are within a few percent fitness from each other. Um, Also, it would be fun if you could move the joints design around between generations. Now, it seems to me, I think I've read somewhere that's something you could not do. Oh, wait a minute. Well, between generations, you still can't. I'm between generations of the evolving neural network. See, now this is a question of what is meant by generations. And again, if we go back and look at the program, what it says generation 27 up in the upper left. That is generations evolving the neural network, not generations evolving the structure. As a matter of fact, technically, uh, there aren't any real generations with regard to the structure. I mean, you could consider each change to be another generation of that structure in a sense, but you're not really, copying it and then making a change and copying it and making a change. I don't know, internally, maybe the program is. There's no way to really tell. But the person who's designing the thing by adding changes is simply evolving the existing structure, not evolving generations of the structure. And so, in that sense of generation, if you were talking about like generations of from one change in the structure to another, yeah, you can do that now. I think that used to not be the case, and you had to delete them and move them. I think I read that somewhere, but I'm not real sure. Don't quote me on it. But as far as being able to move them around between generations in evolving the neural network, I think that's a neat idea. And and there again, if you had the ability for such things to evolve on their own uh, between generations of evolving neural network, it shouldn't be that difficult to also add in the ability for someone to manually go in and tweak um, some of those features and manipulate the evolution, as it were. Another reply or comment on that. Um, Magafago, 24 days ago, commented, do not exist a way to change the total population per generation. Sometimes is better start with a huge population uh, and start lowering the number of population. For example, I started with a spider with 1,000 population per generation, using 40 per batch. Now, after 500 generations, I would like low the population and speed up my simulation. Um, become now because now the spider is close uh, to close of the best way to run. Okay, so basically, what this person is saying here, if I'm understanding correctly, is that there doesn't exist currently a way that you can change the population uh, during the simulation. In other words, you can set your population before the simulation starts. And again, I can show that. You might notice these things are made pretty decent progress here. But I'm going to go ahead and here hit the pause button, and you can see there's a time per generation. There's the mutation rate. There's these couple of settings here I can turn on or off, but no place to change the population per generation. If I click back here, now I could set the population. Say, for example, I go to 2. Well, that was meant to be 2, not 22. Oh, that's right. There's a bug, and I don't know if it's a bug in the program or a bug in the Linux version of the program, or if it's a bug in my Linux installation, but or whatever. But for some reason, whenever I type something in this program, it takes the keystroke twice, or whatever I typed, it duplicates it. And so I can't type 2 in there, but I can type 22. Yeah, I was going to do 2 because it would be more obvious that I had made a change when I click evolved, and you could see there's only 2 of them instead. I don't think it's as obvious, but it should still be somewhat obvious that that's more than 10 now. It's not the number that it was before. And so, yeah, there is a way to change that, but not during the evolution, not during the simulation itself. And now, if we had the ability to change that, it wouldn't change during that generation. It would have to change the next generation, and the way that each generation is generated right now, I do believe it would actually support that. Because my understanding is that the creatures are made in pairs, or rather, the neural networks are made in pairs, and each pair of neural networks is made from a pair of parents. That basically 2 parents are selected somewhat at random, with a slight preference toward those with a higher fitness score, and a division point is selected. Again, my understanding is at random, somewhere within the length of the bit string of the neural network, and the 2 parents' neural networks are divided at that point, and part of one is exchanged with part of the other. So I want to go ahead and upvote this, because I think it's a decent suggestion. And moving on. Let's make that moving on to part 2. This video is getting a little long for most people, so stopping it here, and I hope you'll watch the next part. Thanks for watching.